then there's this deep dark shadow called the umbra. And often these partial lunar eclipses are just penumbral eclipses where it doesn't pass into that cone of the umbra. A total lunar eclipse is when you have the moon completely pass into the umbra. This partial lunar eclipse is passing 95% or so into the umbra. So a sliver of the moon will still be a bit more illuminated than it would have been otherwise. But in general, this is almost a total lunar eclipse, and it will show the moon changing color. We can see why the moon changes color here with this diagram. So what happens is you have the atmosphere of the Earth, and there are different colors that basically get refracted out. And as you move into the umbra, the only colors that are able to make it for the moon to then reflect back to us are the red colors. So this is still sunlight at the end of the day refracting through Earth's atmosphere, but then it goes like this, strikes the moon, and then reflects back to us. But energetically, it's very interesting that we have a full moon when the moon is brightest from our perspective here on Earth. And as we all know, this kind of creates some crazy activity here on the planet. There's a reason the word is called lunatic. Right? Ask any ER nurse or whoever about the full moon effect and they will vouch for it. Well, to go from a bright full moon to a blood red moon and back over the span of a few hours is pretty exciting. And we often see tumultuous events in time link up with these blood moons. Just pay attention and you'll see it. It's very, very interesting. So this is occurring. Here we see an animation from NASA giving us our times for this universal time. So we see the moon will pass into the penumbra. This is the outermost shadow, not as dark as the umbra is. But a lot of people, specifically like Europe, Africa, will see some of the penumbral eclipse. But then it'll start to pass into the umbra, okay? And this phase right here lasts quite some time, about 2 hours. 3:15 universal time is equivalent to about 11:15 p.m. for Eastern Daylight Time. 4:13 will be 12:13 a.m. Eastern Daylight Time. And then we see it moves out again. It's about 2 hours to go from 50% partial to 50% partial. That right there will be 2:11 a.m. Eastern Daylight Time. Pacific time is 3 hours, of course, even further off of that. So this overall partial lunar eclipse lasts quite some time for the west coast of the United States, California specifically. As the sun goes down and the full moon then starts to rise, it's already going to be undergoing this partial lunar eclipse. So we're not going to see the entire eclipse across the entire penumbral to umbral stage and back, but we will see the entire partial eclipse, which will be very, very cool. So here is an excellent video showing exactly what this looks like for the different locations on the globe via time and date. And so here we see our moon, okay? And we also see the Earth. So this is the daylight side of the planet. We see the full moon. These locations, we'll see that umbral. Here is the partial. And then we see it go back to the penumbral eclipse. And then it goes back to a regular full moon. So we can watch that again. So there is our full moon. There's our penumbral eclipse. There is our partial umbral eclipse right there. And then it goes back. So viewable by a wide swath of the world, but notably people in Asia, Southeast Asia, Australia, they are not going to see this at all. They will be on the daylight side when the moon makes this astronomical alignment. And remember, it's not only with the sun and the Earth that this alignment is occurring. We also have Mercury in the mix. Let's talk about this Mercury cazimi. We already have signs that this Mercury cazimi is coming because we can look at our coronagraph view of the sun and we see very clearly there Mercury on the far side shining very brightly. So a coronagraph is a special telescope that puts a disk over the sun. This is the occluding disk right there. That's the sun being represented by that white circle. such that it blocks out the majority of the light from the sun, just like what happens with a total solar eclipse where the moon passes in front, allowing us to see the faint details of the outer corona.